Okay, till now we have discussed about the what is a force, what is center of gravity, what is center of resistance, and where it is present in single rooted teeth and multi-rooted teeth, and also what happens when you apply force through the center of resistance of the tooth, and what happens when you apply away from the center of resistance, and also the different types of tooth movement based on that. Okay, bodily movement, tipping, etc. Now when there is a body and you apply force, sorry, already I have drawn the diagram. When there is a body here and we apply a force passing through the center of resistance, it will move bodily. This we already discussed, and it is, I hope, etched in your mind. You apply force passing through the center of resistance, the tooth will move bodily, it will move equally. Now if you apply force away from the center of resistance, what happens? That is what we are going to see. Now in this second diagram, I am applying a force away from the center of resistance and the tooth is tipping, it is rotating, it is tipping. And again in this third diagram, I am applying a force at a different place but away from the center of resistance. So if you compare the second and third force, the second force is also not at the center of resistance but close to it, whereas this third diagram, the third force is very much away from the center of resistance, almost as far away as possible. So when you see this second and third diagram, you can see that the further away, the distance from the center of resistance to the force increases, the rotation of the body or the tooth will increase. That means if you apply as close to the center of resistance, it will only move like this. If you apply very far away, it will move freely like this. So the rotational tendency of the tooth when you apply force away from the center of resistance, okay, that is called as moment. Moment is nothing but the tendency of the body. Body here I am telling because it's a physics definition, you can substitute the tooth. Tendency of the tooth to rotate when force is applied away from the center of resistance. If you apply force away from the center of resistance, the tooth will rotate or it will tip. That is called as moment, and we can actually calculate it. Okay, so the moment of any, when you apply a force, only this moment is created. Understood? So remember one thing, when you apply a force, you will be applying only the force. You won't be applying any rotation. But because you are applying the force away from the center of resistance, the object or the tooth automatically rotates. The tendency for rotation is called as moment. Okay, and moment is equal to the force into the distance. Okay, force means the more force you apply, more will be the rotation. That is, the magnitude of force increases, more will be the moment, and this distance is nothing but how much far away it is from the center of resistance. Okay, just for example, I am using a physics example. If this is the center of gravity or the center of resistance in the tooth, and you are applying a force like this, see the force is 10 grams and it is in the right direction. Now you should not just see the distance directly like this, how much distance. You should take a perpendicular distance. Okay, you should use this instrument which is called a set square. Okay, this angle is 90 degree, so you move the set square along the line. If required, what we do is we extend the force. This is the force, so you extend the force line of action. Okay, you extend the line of action of the force and then you move a set square like this till it comes to touch the center of resistance, then you draw a line. So this line will be perpendicular 90 degrees to the line of action of the force. So this distance is the perpendicular distance from the center of resistance to the line of action of the force. Understood? So this distance you should take for calculating the moment. So I'll come back to the formula. Moment created by a force is equal to the force into the perpendicular. Okay, this is perpendicular. Don't think this is L, N, 1 and all. This is perpendicular distance. So how to draw the perpendicular distance, you know. I'll just give an example that in this case it is 10 grams of force. Okay, and let's say the distance, perpendicular distance I measured is 6 millimeters. Okay, 6 millimeters. then the moment on this body by this force, okay, it will be, the moment of this force will be force, that is 10 grams, into perpendicular distance, that is 6 millimeter, that is 10 into 6 is how much? 600. 60. So 60 gram, okay, 60 gram millimeter. And unfortunately moment is also a vector quantity like force, so here you have to draw a direction, but here you cannot draw a straight arrow mark like palatal, labial, right, left, up, down, like that, because it is rotation. So rotation can be of two types, as you already know. It can be not the tooth rotation, okay, don't confuse mesiolabial rotation, distolabial rotation here. This is object rotation or tooth rotation completely in the plane. So this is either like this, or that is clockwise, or like this, anti-clockwise. And if you see this diagram, you can see this object will rotate like this, that is in a clockwise direction. So I am going to draw a arrow mark like this. See, it's a curved arrow mark. So this indicates it's clockwise. If it was anti-clockwise, I would have drawn a arrow mark like this. So basically the moment is equal to force into the perpendicular distance, that is in this case 10 into 6, that is 60 gram millimeter clockwise will be the moment created by this force on this body. Clear? Just repeat the example. Now suppose I am applying a force of 100 grams on the tooth, okay, and we know the center of resistance of the tooth is here, that is at the junction of the middle third and cervical 1/3 of the root. Okay, now what you have to do basically first is you have to extend the line of action of the force. Okay, you have to extend the line of action of the force, then you have to use a set square. Okay, this is possible only in the theoretical. Okay, in the clinic don't try all this. In clinic you cannot calculate like this. This is for your research and all that. So you keep the set square like this. So this angle will be 90 degrees. So draw a line. So this line is a perpendicular to the line of action of the force, and you measure this distance. Okay, suppose this distance in this example it is around 14 millimeters. Okay, this is around 14 millimeters. So the moment created by a force of 100 grams applied at a distance, perpendicular distance of 14 millimeter on the labial surface will be, we'll just calculate. The moment of this force will be force is 100 gram in this direction, okay, into perpendicular distance we measured, it is 14 millimeters. So it will be how much? 14 into 100 is 145. 1400 gram millimeter. Now you see how we will apply the direction. This is like this, means crown will move palatally, whereas root will move labially, obviously because this is not through the center of resistance, so there will be uncontrolled tipping. So this direction you see, it is clockwise. Clockwise, anti-clockwise, you people know or you don't know. You go and see a clock, not a digital clock, an analog clock. The hands rotate in one direction, that is clockwise. So if you see this, the moment will be in a clockwise direction. So if you take a force, if I give you a diagram with a force and also tell you the perpendicular distance, you should be able to calculate or find out what is the moment created by that force on the tooth and in which direction.